Okay, here is another type of optimization problem. If you look at this, the big question here is what is the least amount it'll cost to run the electricity to the island from the powerhouse? Of course, looking at the problem, you have the island being a half mile from the bank, and then the power line's exactly 3 miles down the river. And that's the picture. The additional information that we have is that it costs $2,500 per mile to lay electrical wire underground along the bank. We're talking along here. And $4,000 per mile to lay the electrical wire underneath the water here. And again, the question is what's the least amount it'll cost? The big question is cost. So that's our focus. We're going to have to label this side X, label that Y. We're going to label them because we care about them. And then our focus is going to be the cost is $2,500X. Remember, the $2,500 is how much it costs to lay it along the bank, and the $4,000 was what it costs to lay it in the water. But the problem is that this has two variables, and we're going to have to find a constraint to substitute for one of those variables. All right, so we go back to our picture. We notice that we can label this length right here 3 minus x. And we have a right triangle right there, which is great because that allows us to come up with a constraint from Pythagorean's theorem. And that's exactly what we're going to do. 1/2 squared plus 3 minus x squared equals y squared. And we can solve for y with that. And go back to the original picture and our original focus. And we know that we have this formula for y, and we just substitute it in. Right, this right here just goes in for y. So we've got that cost. It's in one variable. Notice we've only got x's in here. Now we just need to go graph this to find the minimum. So here's the information again. In terms of typing it into our calculator, we need to use the variable x, and our y1, right, is actually our cost. The window's important here because if we make our window too big or too small, it's not going to make any sense. So remember, x is this point right here, and there's no way it can be bigger than 3, which is why I have the max at 3. And of course it's a length, so we don't want it to be negative. That's why I have the 0. The y value, be really careful. I labeled this y, but the y in the calculator here is not y, it's the cost. So my y min is going to be 0 right here, and it's 0 because of course it's not going to cost a negative amount. And y max, you have to play with this a little bit, but if you play with it a little bit, 15,000 seems to be a good one. If you're too small, you can always make it bigger, etc. Anyways, with that window, you graph it like this. I went ahead and already found the minimum on that graph. And now we go back and ask ourselves, what was the question that they asked? And the question they asked is, what is the least amount it'll cost to run electricity to the island from the powerhouse? That's what your y is. Remember, your y is your cost. Your y1 is your cost. And so the answer is it'll cost a minimum of $9,061.25 to run electricity to the island. And you're done with the problem.